Hi everyone, my name is Ashish Agarwal, and I'll be delivering this lecture to you. So before commencing the session, just a quick round of update regarding my YouTube channel, which is youtube.com/Ashish Agarwal _GG. So if you haven't visited the channel, I would request you to do visit the channel and do like, share, and subscribe the channel. The channel is dedicated to Oracle Golden Gate related videos. Thank you.
We are now going to discuss about how to secure Oracle GoldenGate 23 AI using certificates. So when we reach the URL of Service Manager or our deployments in Oracle GoldenGate 23 AI, so how do we reach? We provide the URL as http ://192.168.56.101:7820, right? So this is what we are reaching out on HTTP. Okay. Now, if we try to reach it out on HTTPS, it will fail because right now our deployments are unsecured. They are not secured. So one of the major question which we receive is how to get our deployments or service manager in secured mode. What are the ways to do that? So the way to do that is you need to import the certificates during the installation so that it becomes secure. So you must have seen a lot of, like, when you reach out to Google or any other website, those are secured websites, right? So if they are secured website, if that means they are using the SSL certificates. Okay. Now there are multiple level of certificates which are required during installation. Okay. So during GoldenGate installation, when we talk about certificates, it is imperative to know what are different types of certificate. First of all, what are certificates? Then why do we need it? And what are different types of certificates? Because see, to make the site secured, right? So basically you are making it secured. So there should be some certificate which is to be provided. So what are different types of certificate? Let us see. So to make it easy for you, what I have done is I have created a analogy for it so that you can better understand what exactly different types of certificate means. Okay, so understanding certificates in GoldenGate with the analogy. So basically what I'm trying to do is in GoldenGate, there are three types of certificate, first of all. Okay, which you in when we are working with secure deployment, there are three types of certificates. What are those? First is server certificate. Server certificate. Second is client certificate. And third is CA certificate. So CA certificate means certification authority. Okay. So in this scenario, basically, what is server certificate basically? So server is basically your service manager distribution server. So when I log into service manager, OGG admin, OGG admin. So all all these servers, whatever, either the service manager or all these servers which are running, they require a certificate. So, so server certificate corresponds to these servers. Okay. Second is you have client certificate. So client certificate is basically, so server certificate is basically you are server is trying to authorize itself that yeah, it is the authorized server. It has its own certificate. Same way like client. So client is how do you try to reach out these servers? Either through web browser like Google Chrome or either through admin client or REST API call you make, right? So those require client certificate. Okay, so that the response can be sent to the correct client. So client also, so that's why you have here client certificate. Okay. And then you have a CA certificate. That means that the server certificate and client certificate should be signed by a certification authority, right? So basically, server generated its own certificate, client generated its own certificate, but someone needs to authorize it that yes, this is the authorized certificate by the server or this is the authorized certificate by the client, right? So who is going to authorize it? It will be authorized by a CA. CA stands for certification authority. So that is called as certification authority certificate. This is also called as root CA certificate. So many a times you may hear this. This is also called as a root CA certificate. Okay. Now, to make it better understandable to you, what I did yesterday was I was working and I was thinking like how can I make it better understandable to you, because there are multiple types of certificates and certification authorities involved, and then along with that all these certificates requires a private key as well. Means along with it all these certificates requires a private key. So what are those private key? So I tried to create a analogy for it so that you better understand it. So what analogy I was thinking that what better analogy I can give. So I decided that like when we were working when we were in school, right, we used to get the report card at the end of the session, right? And then teacher used to give it to us being a student, and then so that we know that so that teacher know that it has been signed correct, means their parents have reviewed their report card, so they used to get it signed from our parents, right? So this is what the best analogy I thought that will make you understand in better way. So imagine basically here there are three parties involved. First is child, second is teacher, and third is parent. So in this scenario, consider child is a Golden Gate client. So admin client or web UI. So you try to so Google Chrome, you try to reach the server. How do you try to reach the server? Using Google Chrome or REST API or admin client, right? So consider child as a Golden Gate client. Then teacher is a server, like your distribution server, administration server. So all these are servers, right? So they requires a certificate. So teacher is a Golden Gate server and parent is a certificate authority, a trusted authority that confirms identities. So basically CA is a certification authority which confirms the identities of your child and teacher. Okay. So let's see how these certificates fit in. So server certificate now. So what I'm trying to do right now is I'm trying to make you understand why these certificates are needed here and what is the role of each certificate. I made you understand that in GoldenGate there are three types of certificates we need: server certificate, client certificate, and those certificates should be signed by a certification authority. But why do we need it? Because initially, when I started with this GoldenGate certification secured deployment, this first question used to be in my mind almost for a year. Like, why I need server certificate? What is the need of client certificate? Whenever I used to do a new deployment, I used to get confused because the concept wasn't clear to me. Now, I thought like because I'm making this understandable to you, I need to come up with an analogy so that you better understand, so that you better understand what each certificate does. So that's why I'm trying to make this easier for you. Okay, so child is a Golden Gate client, teacher is a Golden Gate server, and parent is a certificate authority. So server certificate. So when the teacher gives out the mark sheet, the child needs to know, am I really getting this from a real teacher and not a fake one? Right? So, say for example, you gave the maths paper, right? And the certificate has to come from your teacher, right? How do you know whether it is coming from a real teacher or not? So, for that purpose, the teacher shows you an ID card issued and signed by the parent. So parent knows that this teacher, the parent hired the teacher for you, right? So teacher has an ID card issued and signed by the parent, so that the child can verify teacher's identity. So this is the reason server certificate is needed, so that the client, Google Chrome, when it reaches to the URL, it knows that the server certificate is issued, and by verifying the server certificate, it can verify the identity. Okay, so the teacher shows the ID card issued and signed by the parent. Okay, so in GoldenGate 23 AI MSA, the server certificate identifies the GoldenGate service, like your admin service or distribution service. And this server certificate is signed by the certification authority, so that clients like admin client web UI can trust it. It typically stored in service manager wallet. Okay, so this is what your server certificate does. Now, child certificate. Now teacher is giving to the child, so child has to verify the teacher. Same way, when teacher is giving the mark sheet to the child, the teacher also wants to ensure that the child is genuine, right? So are you really my student, or an outsider pretending to be one? So the child also presents an ID card to the teacher signed by the same parent. So that certificate needs to be signed by the same certificate authority. So the child, what it will do is, it will present his or her own ID card. In this scenario, we call it as a client certificate signed by the same parent. So it is used for mutual authentication, the client certificate. The server verifies the client certificate to ensure only trusted clients connect. So basically, the whole purpose is to ensure that only trusted client can connect to it. Okay. Now, third is CA certificate. Now, this is another important thing. So server certificate is cleared, client certificate is cleared. Now, third comes CA certificate. CA means certificate authority. So in this scenario, in this analogy, it's a parent signature, right? So everyone trusts the parent signature. So each organization has a certification authority. Okay. So everyone trusts the parent signature. Both the teacher and child knows it. If the teacher's ID or the child's ID carries that signature, everyone can trust it's real. So if your teacher's ID, just like when you go to if you see your office ID cards, if they are issued to you, you will notice that it is signed by someone. Or any certificate, like if I talk about any degree which is being issued to you, or any certificate which is issued to you in terms of accomplishment or good work or rewards which you have been which you have got, right? You must have seen all those are signed by someone. So those signed by someone is basically, it's a trusted authority. So same thing here. CA certificate is nothing but the signature provided by the authority whom everyone trusts. So whoever carries that signature, it means that it's a real one. So the CS certificate is like a known signature of the parent. It's shared publicly so others can verify any certificate signed by that parent. So in GoldenGate, you import the CA certificate into both clients and server. That allows both sides to validate each other's certificate. Okay. So when your GoldenGate components, now how does it works in GoldenGate 23 AI microservices architecture? So basically what happens is, server sends its server certificate. Client is basically, see, you have to understand basically what is client. So client is a Google Chrome right now. If I try to log in, so if I do 192.168, it's the client who will try to reach the server, right? It's a client who try to reach the site, reach the service manager or administration server or distribution server, right? So if the server is secured, basically, if the service manager is secured, so what happens is, in that case, server will send its own certificate, server certificate. Right now, it's not secured. So that's why you don't see it is not sent. But if it is secured, once we install it, you will see. So server send its own server certificate. Then client check if it's a trusted CA certificate. Okay. If mutual SSL is enabled, child will send its own client certificate as well to the server. Server validates it using the CA certificate. Once trust is established, secure TLS communication begins. Okay, so this is how your certificate are classified into. So how it works is the client sends a request to the GoldenGate server. For example, web browser. The GoldenGate server responds by sending the server certificate. The client validates basically the web browser validates the server certificate. This is done with the information of signing CA certificate that was imported into the browser certificate management system. Once client verifies the identity of the server, further negotiation happens to exchange information securely using HTTPS. The GoldenGate server validates the client web browser by the credentials used to log into the web UI. So just like we try to reach to Google, so Google also is a secured. So if you go to Google, right? So if you see it's HTTPS. So HTTPS means it's a secured deployment. Basically, it is using a secured deployment. HTTPS means it's secured and HTTP means it's unsecured. If I try to reach it on HTTP ://google.com. I think it's automatically, even though I give HTTP, it is HTTPS right now. So that's why if we try to reach it on HTTP, because it's stored in my cookies and browsing history. I think that's why it is automatically resolving to HTTPS. But if you try to reach it out on HTTP, it won't, because what happens is with the certificate, this browser, our Google Chrome, is able to validate that the server certificate is authenticated. If the server certificate is authenticated, that means it's a trusted certificate, and then it is able to connect. That's why you must have heard or seen, like, whenever any uh, wherever any credit card information are shared or you make a payment, they always say that it is SSL secured. So SSL secured is this. Basically, their websites are they have SSL certificates, and when they have SSL certificates, what happens is the hackers, the sites are basically less prone to the hacking, and your data, whatever data you do, it goes over the secured layer. So that's why it is required. It is mentioned that the website should be secured. It makes whatever transactions are being done, those transactions goes over a secured layer. And when it goes over a secured layer, you're, like, say for example, you're making payment via credit card or over from a bank account, your details are not exposed to the scamsters. That's the major thing. Okay, so now we discussed about there are three types of certificate. First is uh, first is server certificate, second is client certificate, third is CA certificate. Now, again, another thing is in certificates, there are two types of certificate. Now, you can create this certificate as a self-signed. Now, there are two types of signed certificates. So when you create these certificates, right? So there are two types of certificates. First is self-signed certificates, and second is trusted certificates. So self-signed certificate means you use them in non-prod. It is not recommended to be used in prod environments. So in self-signed certificate, what happens is you are signing it yourself. There is no CSR. CSR stands for certification signing uh, resource or certificate signing authority, something like that. So trusted certificate means every organization has a CSR. Okay, CSR stands for just one second. CSR in certificates. CSR in certificates. What does CSR stands for? Certificate. So you send a CSR certification signing request to the certification authority. Okay. So CSR is certification signing request. So in trusted certificate, you send a CSR to CA, certification authority. Okay. In self-signed certificate, so in trusted certificate, it is signed by a trusted CA, trusted certification authority. So basically what happens is certificate authority, each organization has a certificate authority who has authority to sign the certificate. Okay. In self-signed certificate, you sign those certificate yourself. As the name suggests, you are basically authenticating that certificate. You are authenticating that particular certificate by your own sign. So basically, it's something like I create my own certificate and I sign it myself. It is something like that if you want to understand it in a better way. So if I'm creating my own certificate and I'm signing it not by myself, that means I'm not getting them signed by a trusted certification authority, right? So there are two types of certificates: self-signed certificate and trusted certificate. So I have this blog as well. Okay. This is good blog to read. So there are two types of certificate commonly used. Trusted certificate come from common commercial business certification authority. There are different certification authority available. Of course, now you may say, why, what is the advantage? Why don't we always go with the trusted certificate? Because trusted certificate costs you money. Okay. No, so self-signed certificate, no cost, no fees, independence from CA certificate provider. Cons are no trusted validation, of course, disruption and errors, limited browser support. Now, one more thing you will notice is when we set it up as well, when we create a self-signed certificate and when we import it into, means when we use it into our GoldenGate deployment or anywhere, so you will see that it will use HTTPS, but still it will show you non-secured at the browser level. The reason is because we are using the self-signed certificate. If you are using the certificate signed by a trusted CA, just like your Google or any other website uses, in that case, it won't show you that you are reaching out to a, many a times you must have seen that as well, right? You're reaching out to a website which is not secured, even though it is HTTPS. The reason is they must be using the self-signed certificate. Okay, so self-signed certificate has compliance issues, operational overhead, etc. However, if you are using trusted CS certificate, it is a confirmed identity, of course. Okay, then uh, strong encryption, simplified management, compliance adherence, and risk reduction. And it also involves costs, of course, right? So fees to get a certificate generated or renewed. You will need to get in contact with a CA certificate provider. Okay. So what type of certificate you use depends on your environment. Okay. Now, if your website is on internal or intranet network where none of the websites are external for testing and working with non-sensitive data, then you can use self-signed certificate. Consider using CA certificate when you need security and validation of your domains so that it can be trusted publicly. Okay. So in non-prod environment, you can use self-signed. However, in prod, it is it is recommended to use trusted certificate, even though it costs. Okay. Now, in 23 AI, so earlier it was SSL protocol which was used. Now there is more advanced protocol which is called as TLS. TLS is more advanced protocol in terms of security, which is used to send the data over the network. So TLS, whose predecessor was SSL, is a cryptographic protocol that provides security for data sent between application over the network. The TLS protocol addresses authentication, confidentiality, and integrity of the network configuration. Okay. So now what we are going to do is we are going to see how we can use this, how we can create these certificates, and then how we'll be creating the secure deployment. So what we need is we need two certificates, server certificate and client certificate now. Okay. Now, along with that, what you will notice is when we create it, okay, along with that, there would be a private key which would be created with them. So along with the certificate, there is a private key which is created with each certificate. So what is the private key? So private key is, if I have to give this analogy of parent-child only. So when the teacher signs the report card, so they use their own pen. So pen is something like a private key, which ensures that this certificate has been signed using that particular pen. So private key, I'm just making you understand with the analogy that if you are using the particular pen to sign, that pen will be a key to verify the certificate. So basically, when a certificate is generated, a key is also generated with it, which verifies the certificate. A private key is generated. Okay. So what we are going to do now is we are going to create server certificate, client certificate, as well as CA certificate, which we also call it a root CA certificate. And along with that, each certificate private key will be generated as well. Okay, so generating the certificate is pretty easy. We are going to use self-signed certificate for this training and development. We are going to create the self-signed certificate. If you need a trusted certificate, you need to get it by you need to get that signed by a trusted authority. There are private trusted authority which works, or if you are working in an organization, each organization has a authority which basically signs the certificate for you. Okay. So if you're using the trusted certificate, you can generate the certificate or get it signed by a trusted authority, or trusted authority can directly give you the certificate. Okay. So now what we are going to do is we are now going to create the certificates. It's easy. It's not that difficult at all. Okay. So what we are going to do, we also have an activity guide available for how to create the certificate. So the activity guide number is 26. We are going to use activity guide number 26. Okay. So what we are going to do now is, there is a question, are these certificate links with licensing? No. Licensing is a different part. Okay. So now what we are going to do is we are going to create the self-signed SSL certificate. So what we have done is we have a script available for it. This script is also available on Oracle MOS support. The link for the MOS, this is the MOS ID. If you want to refer to, this is the MOS ID 3042392.1. So this, so it tells you just need to download it and create the certificate. So what you're going to do, you're going to download the script. So I'll open it in Notepad. Okay, this is the script which gets opened for you. Okay, now in this particular script, what you need to do, you just need to change this FQDN 0102. So what you will notice is there are different things here. First is server 1. Basically, server 1 is source server, server 2 is target server. So the advantage of this script is it generates the certificates for you. In this script only, you can generate the certificate for your source as well as target server. Okay. Then when the certificates are generated, they have some password associated to it. So you need to provide the password. So this is the password. You can change this password if you want to. And the certificates are valid for number of days. So if you see this certificate, so it uses first of all OpenSSL to generate the certificate. If you want one more thing, you can directly generate these certificates. So basically what this script does is you have different options to generate the certificate. You can either use OpenSSL or you can use Aura PKI to generate these certificate. And from 23 AI, it requires the certificate in PEM format. Okay, so you can generate the certificate in any way. If you don't want to use this script, you can directly use OpenSSL and generate the certificate if you want to. That's one way. Okay. Another way is you use the script, which is available and which is easy as well. Right. So I prefer the easy way because scripts are available to generate the certificate. What you need is you only need to change this FQDN 01, which is for source. So source FQDN for us is GGate 18 and target FQDN is, it requires the domain and everything. If you have to check the domain, how can you check? Like you can do hostname -f, it will tell you. So for our training provided VMs, the source is GGate 18, target is GGate 28. Then if you want to change the passphrase, you can change. So I'll keep it simple. Welcome 1. Okay. And then there is one more thing. Number of days. Okay, yeah, here. So you see this. This certificate will be valid for 7,300 days. 7,300 means approximate 20 years. Yeah, approximately 20 years this certificate would be valid for. 7,300 divided by 365. Yeah, for 20 years, this certificate would be valid for. So if you want to change this number of days as well, you can change this. Okay. So you can see this will generate lot of certificates for you. I'll tell you. Okay. Okay. Once you have changed this, so only these parameters you need to change. First is this. Second is FQDN. First is FQDN1, FQDN2, then passphrase and number of days. Only these you need to verify. Then automatically what it does is it creates this particular directory for you. Okay. Let us do now. So I'll do Control A, Control C. I'll save this. Okay. Now I'll go to GGate 18 or GGate 28. I'll go. I'm under /home/Oracle, right? So what I'll do, I'll create the file with the same name. So I'll create the file with the same name. Setup certificate underscore two deployments underscore single root ca.sh under /home/Oracle. Follow activity guide number 26. Okay. Now I'll copy the content, whatever I have prepared. Okay. Save it and close it. Once it is done, now you can go below. In the script, I have mentioned that as well, like modify GGate 18, modify this, modify passphrase if you want to. Okay. Now it says set the execute permission for this particular script. And then execute the script. So right now I'm doing it on GGate 28. So it will generate server and client certificate for you. See, it has generated server and client certificates for you. So if you go to OGG underscore certs, here you can find all the certificates. So you see here, server certificate GGate 18 is here and corresponding key. So this key identifies this certificate. So this certificate has been generated using this particular key. Same way, server certificate GGate 28 is here and corresponding key is here. Client certificate is this and corresponding key for it is this. So they have mentioned client certificate, they have named as disk client. And then you see root CA certificate and its key is this particular. Okay. So now when you install GoldenGate on GGate 18, you will use this GGate 18, that is source, you will use this key and this certificate. When you install GoldenGate on GGate 28, you will use this certificate and this particular key. Okay. Okay. So now next step, what we need to do is once the certificates are created, you need to send the same certificates to GGate 18, the other site as well. Okay. So we'll SCP this, SCP -r ogg.certs to Oracle at G. Why did I give colon here? Oracle at GGate 28. No, 18. We are sending it to GGate 18. Colon /home/Oracle. You can generate this on GGate 1.8 and send it to GGate 2.8, or vice versa. You can create it on GGate 2.8 and send it on GGate 1.8. Both ways, okay. We are using the same same set of certificates, just different certificate we'll use. We have generated the certificate for GGate 1.8 as well as GGate 2.8, both on one server. Now we are transferring whole set of servers to the other. So these are self-signed certificates we are creating, okay? Are you sure you want to Oracle? So basically what we have done is we have sent now the these certificates, whatever were generated, we have sent them to GGate 1.8 as well. So certificates are now generated. Now, once the certificates are generated, next is we need to create the deployment. Okay. Now, let me tell you one thing. Until 21C, if you have created a non-secure deployment, and if you want to create a secure one, you have to do a new setup. Everything is required. Okay. In 23 AI, if you have done a non-secure deployment, and if you want to convert it to secured one, there is a way to do using reverse proxy. Or second option is you do it using during a fresh installation. So we are going to discuss about when we do a new deployment, how do we create a secure deployment. Okay. So now what we are going to do is we are going to create a secure deployment. So to create a secure deployment, now we'll log into our, because we'll do it using GUI. I won't use putty then. I'll go to GGate 1.8 first. We'll do the installation over there and then we'll do GGate 1.8. So Oracle. Okay. So what we are going to do is xhost space plus, we are setting up the display. Now, okay. So if you go to, this is PWD, copy this. /home/Oracle cdogg_certs. So we already have those certificates here. Now you can see, right? Now what we'll do, we'll do a deployment now. So GoldenGate installation is already done. Now we import the certificate while creating the service manager, etc. So now we'll create the service manager and other stuff. Okay. So what I'm going to do is I'll go to data app Oracle. Here I'll create one folder, mkdir ogg23ai underscore secured. Okay, so this will be secured one. Under this, I need 3 deploy. No, I already have 23 AI. Okay, wait. Sorry. I already have 23 AI installed, right? So I need to create service. Okay, so what I'll do, I'll create service manager home and deployment home under here. So here, what I'll do, I'll mkdir ogg23ai underscore sm underscore secured and mkdir OGG23 AI underscore deploy underscore secured. MV. I'll make everything small. Okay. So I have these two directories created. So basically what will happen? Service manager will come in this location and deployment will come in this particular location. OGJ23 AI underscore SM underscore secured PWD. I'll copy it. Now, CD OGG23 AI slash OGG23 AI underscore MA slash bin. So we'll use OGGCA.sh. Now, okay. So we'll create a new service manager now. Okay. So the software home would be this, correct? Then deployment home. Deployment home would be basically service manager home here. So service manager home will be this OGG23 ISM secured, right? Then host name we need to provide. Host name is 192.168.56.101. Port number we need to provide. Now this port number should be something where nothing else is running on. So I'll provide the port number, say for example, 8820 or any port 8001. I'll provide port number 8001. Okay. Now here you see security now. So if you don't have certificates, we just untick enable security box. But because our certificates means this is our going to be a secured environment, so we'll enable the security over here. Now we need to import server certificate, server private key, and server CS certificate. Okay, so we'll do all that. So I'll click on browse. We'll go to /home/Oracle OGG underscore certs. Here, so server certificate would be server ggate18 underscore cert.pem. Then key would be this server ggate18 underscore key. And server CS certificate would be this root CS certificate, right? Select. Click on next. So you have imported the certificates. Means you have provided the certificates over here. Now it will ask for the username. We'll provide OGG admin. OGG admin. OGG admin. Click on next. Now deployment name you need to provide. We'll provide deployment name as DP. TLS or SSL is a protocol. Certificates are not SSL or TLS. Protocol, basically the handshaking happens over either it uses TLS or SSL. Now it uses TLS because it's the advanced security. So there is a question whether the certificates we have generated, they are SSL or TLS. You can check the script as well. It will give you the answer. You see? So in the script, you never use whether it is going to be a SSL or TLS certificate. Script, it just certificates are certificates. The handshaking, what happens over the network, it uses that particular protocol. So now TLS is the latest protocol which is being used. But good question. I like that question, Mohit. Okay, so we'll name deployment name as DP1 underscore secured one. Okay, deployment home would be, just 1 second. DP1 underscore secured one. Deployment home would be OGG23 AI underscore deploy underscore secured. Right? And then you need to provide the ports for admin server, distribution server. So it will automatically use 8002, 8003, 8004. And then you need to provide the TNS admin location and replication schema. So TLS, the TNS admin location would be echo dollar Oracle underscore home. Copy. So TNS admin would be this /network/admin. And replication schema, we can give C ## source GG1. When we want to change it later on, you all know we can change in the globals file. Click on next. Now we are going to use the same user for deployment as well, like to log into admin server, same as service manager, OGG admin, OGG admin. Click on next. Now, if you want to save the response file, you can save it. If you want to do any silent installation later on. And then click on finish. You can verify anything if you want to do. Click on finish. So now what it will do is it will do a secure deployment for you now. So there is a question, would the redeployment will TLS also require again initial load and all things again? No, you can just move your directories from older to the new one. I'll show it to you over this. So you don't need, you just need to ensure that older setup is stopped and new is. So basically right now what we have done is we have created a new deployment. Now there is a question from Sunil, as I answered earlier as well. Sunil has a question. Can we also do existing unsecure to secure one? So the answer is until 21C, it wasn't an option. From 23 AI, they have given an option. You can do it using reverse proxy server. There is an option. But during this session, we are going to discuss about new installation, how to set up new deployment using. Didn't we give the client certificate during installation? Is it?
No.
We should
There
have
was
given.
option for client certificates also.
Yeah, we missed that.
Did we miss that? Okay. Let me do a new installation then. If I
I think
missed that. Just 1 minute. Let me see.
Yes.
Okay. Okay. So we can do the uninstallation as well, but we'll do that uninstallation later. I'll do fresh installation again in separate directory then. No worries. I think I missed that. Okay, then. Client certificate. You need to give the client certificate as well. I'll create a new service manager. Deployment home would be, no, not this one. OGG 23. Let me go to this location. Data app, Oracle, OGG 23i underscore secured. Select. I cannot use the same home now, so I'll have to choose the different home now for service manager and deployment. 101. Port number also, because I'll choose a different one for now. Port number I'll use 8051, for example. Enable security, we'll use the server certificate, which is under /home. /Oracle OGG_certs. This is the server certificate. Then key. Then root CA certificate. Here it is. Click on next. I'll create a new one then. I think it may not allow us. I'll use secured_1, for example. Okay. We'll use OGG admin. Okay, we didn't provide client certificate here. Okay, we need to provide. Deployment home, DEP1_secured_1, for example. Deployment home would be /data app Oracle. What path we gave? We need to give this. Let me go back. So this will be secured1 / OGG_23AI_secure. OGG23AI SM_secure. This will be that. Because this is service manager home, right? The best part is GoldenGate automatically create these directories. Even though these directories are not present, it will automatically create them. Same way, deploy_secured. It will use these port numbers. Then we need to provide the client certificate. So client certificate is under OGG certs, and we'll provide the client certificate. And then we need to provide the private key and then root CA certificate. Then we need to provide the TNS admin. Echo $Oracle_home. /network/admin. And application schema C # source GG1. Click on next. We have provided everything. Next. We'll use same as service manager. Next. Finish. So now it will create. So you can see we are having multiple service manager under one server. So it's okay. No worries with that. So you see, it is doing multiple things like creating the deployment, adding the certificates, then configure security, and then it will verify the deployment. So multiple steps. So when you are doing secure deployment, there are additional steps which are created. So once it is done, you will see that we'll have a secure deployment. Okay, so configuration of Oracle GoldenGate was successful. Now we'll try to reach out to that particular. Because we are using self sign, so http://192.168.50. The port number we have given is 8850 or 8851. 8851 we have given. We won't be able to reach over 88 because we have given HTTP. Now I'll give HTTPS : sorry, 8051 we give, right? Okay. So see, it is HTTPS, but it says not secured still because we are using self-signed certificate. Okay. So we can give proceed to. There is an option which is given, means I tried multiple options. I have tried multiple options. You can try it if you want to. In this particular blog, if you noticed, he has mentioned that, and I tried it. it I wasn't successful. You can try. It says that over here as well. He was also facing the same issue. He has mentioned that, like, because you are using the self-signed certificate, so that's why it will show you. So what you need to do is, uh, if you apply the CS certificate explicitly to a browser as trusted, you guarantee that the certificates are trusted. I tried it, but it isn't working for me. But yeah, the issue is because this certificate is not trusted. Basically, just because the certificate is self signed, that's why. So just to let you know, the steps what he's mentioning is, what you can do is you can go to settings, then go to privacy and security, then go to security. Here you can find manage certificate options. So you can, if you want to do, you can import your certificate under trusted root certificate and see, like, import and provide the certificate and see whether this particular issue is gone for you. I tried few things. It didn't work for me, to be honest. Like, I have been trying it for a long time. Maybe it requires browsing history to be cleared, cookies to be disabled, few things it requires. But because there are some sensitive things on my system, maybe because of that. Okay, there's a question in production, whom to ask for trusted certificate. So each organization, you need to find someone from your organization who can do that. So each organization has a trusted source who provide that certificates. You need to get it from that. In production, it is never recommended to go with self-signed if the website is out going over the network. If it is internal and over the intranet, then you can go with self-signed. But again, that call needs to be taken by your organization because it's related to the security and other stuff. So if you ask me or Oracle or any other guy, the recommendation would be go with secure deployment always. Okay, so now you can see we are able to reach where we were able to reach. Yeah, this is secured one, but this is using HTTPS. Only reason why it shows not secured is because we are using self-signed. If it is trusted certificate, you won't have seen this issue. Okay, now give OGG admin, OGG admin. And in fact, your deployments would also be, see, DEP1 underscore secured underscore 1. So if you go to admin service, this is also secure. Again, why it is showing it is using HTTPS only, but why it is so showing not secured is because of self-signed certificate. And it is known. So anytime, like say any organization or any scamster say to you, this is another way to identify, right? So any scamster say that your website, my website is secured, we are using the certificates, we are using SSL handshaking. They say, see, in common terms, it is said that we are using SSL certificate. The thing is, the certificates are not SSL or TLS. Certificates are certificates. The handshaking which is done over the network is SSL or TLS. Okay. But in common terms, it is called as SSL certificate. Okay. Just like we call when DGCam were getting popular, we used to call them as DGCam. But DGCam was just a product name. It wasn't a product, right? Product was camera. So it's something like that. So SSL certificate is a terminology which is getting famous just because we call it SSL certificate, but because it uses the protocol over there. That's the thing. So if anyone says that they are using HTTPS, their website is secured, and you are able to see this not secured. So this is a first no-go for you because it means they are using self-signed certificate or their certificates are no longer valid. What happens is your certificates also get expired when you're using trusted certificate. Like say, for example, I have my own website, right? So this is my website. Okay. So it is also on HTTPS. So what happens is I have to regularly get every year, I have to get this certificate renewed. Every year I have to get. I pay for it, of course. So what happens is when I get it paid, when I pay and get it renewed, what happens is I'm paying for the certificate authority to validate the certificate which I'm using. So every year the renewal comes and I have to pay for the certificate. So same way, each organization has their own trusted certificate authority, and you need to contact them if you are working in your organization. For and production, it is recommended to use trusted certificate only. Okay, so now you can see you are able to reach out to your admin server, distribution service, performance metrics service, etc. In the same way, you will be installing GoldenGate on the GGate to it. So you will follow the same steps. Only thing is, when you install GoldenGate on GGate to it, you will have to use the server GGate to it certificate and key as well, corresponding key as well for it. Apart from that, client certificate, everything else, root CA certificate, they will all remain same. So also, one more thing, you can see these certificates over here. So if you go to under service manager, if you go to certificate management, so whatever certificates you are using, you can see over here. See, we have used these certificates over here. It shows you when these certificates are getting expired. You can always replace, like say, for example, your certificates are changing, you can replace. And if you want to get the details of your certificate, these are the details you can get. Okay. So this is how you create the secured deployment. You make your GoldenGate secured with certificate. So if you secure your GoldenGate instance, secure HTTPS, secure HTTP, which is also called as HTTPS, will be used. So there are two options of setting up a secure GoldenGate instance. First is you can choose to enable a GoldenGate. You can choose to enable a secure configuration at a deployment creation time. In this case, you must apply the certificates to the system. Okay. Second is if you have created a non-secure deployment, then you must secure the environment with a reverse proxy. Okay. So we have discussed about the first option, how to create the deployment, how to secure a deployment at the time of deployment creation. Okay. And there are two types of certificates which are commonly used. Trusted certificate, which is from a commercial or business certificate authority, and second is self-signed certificate, which are created on your own with Aura PKI or Aura OpenSSL commands.